aiding human comfort. Sometimes you might have noted smoke coming out of the fan. What may be the reason for this? Aging, worn-out bearings, and insulation failure are the reasons that cause the winding of the motor to burn. Now, we need to rewind the motor to make it work without hindrance again. The following tools, materials and machines are required to rewind the motor. For removal of the fan, we will need 1. Insulated cutting plier, 2. Screwdriver set, 3. Spanner set. For removal of bearings, we will need 1. Bearing extractor, 2. Wooden hammer, 3. Steel hammer. For winding removal, wire cutter and insulated cutting plier is required. The equipment needed for rewinding are scissors, that is for cutting insulating papers, Millinex insulating paper, that is for slot insulation, wire gauge, that is for measuring diameter of the wire, super enameled copper wire, which is the material of the windings, and manual coil winding machine. For soldering, that is for joining coils, we will need soldering iron, soldering lead wires, soldering flux. Having seen the tools, materials and machines required for rewinding, let us move on to the steps involved in rewinding process. Step 1. Switch off the supply. Step 2. Disconnect it from the supply and dismantle from its position. Step 3. Remove the capacitor from the windings. After the removal of capacitor, ensure that the capacitor is discharged by shorting its leads to avoid electric shock. Step 4. Open the housing by tapping. Step 5. Removing the bearings by using bearing extractor. Step 6. Remove the complete windings. Before removal of the complete windings, the number of coils of running and starting windings should be noted. In this example, number of coils of running and starting windings are 12 each. After this, we need to remove all the coils. Then, the gauge number of the coil has to be measured. From the gauge number, we can get the standard diameter of the wire. For example, copper coil used here has gauge number 36 with diameter 0.193 mm. Using SWG wire gauge, we can easily find the gauge number, which in turn will help us to determine the diameter from the standard table. The final data to be recorded is the number of turns of each coil in running and starting windings. For example, in this image, the coil has 5 turns. After collecting the data, the stator is cleaned by pressurized water and dried. Now, the insulating papers are cut into suitable sizes and fitted into the stator slots and made ready for rewinding. Winding coils can be done in 2 ways: manually for small-scale production, automatically for large-scale production. Let us see the manual process now. First, the starting winding is rewound, and then the running winding is rewound. While doing winding by an automatic machine, the stator is set to an automatic rewinding machine where the coils are wound on the stator quickly. In both the cases, the inner winding called the starting winding is completed first. After this, the outer winding called running winding is completed. This is adapted in order to avoid practical problems. Now the windings are provided with external leads of specific colors in order to identify them. Sleeves are provided after joining external leads with their windings. This is done to avoid short circuit. One end of starting winding and running winding are connected together and is connected with red lead. Another end of starting winding is connected with blue lead and running winding is connected with black lead. Now the fan windings are tied with threads, varnished and dried. Also, we can test for continuity and insulation damages by means of a series bulb as described here. One end, a bulb is connected to one of the points of a wall socket and the other end to the winding under test. The remaining points are connected to the remaining end of the winding. Case 1. If the bulb does not glow, it means that there is open circuit in the winding. In this case, the coil should be traced for open circuit and then corrected. Case 2. If the bulb glows bright, it means that there is short circuit in the winding. This has to be again traced and rectified. Case 3. If the bulb glows dim, it means that the winding is perfect. The same procedure has to be followed for the other windings also. After ensuring the good condition of the windings, shaft is assembled into the case of the fan. Now the capacitor is fitted on the shaft. The capacitor is required for the following reasons. 1. To produce self-start by providing rotating magnetic field. 2. To improve power factor. 3. To improve overload capacity of the fan. Then the electrical connections are made by connecting one end of the capacitor to the starting winding. Then the other end of capacitor and one end of running winding are connected to the neutral terminal of supply. The common terminal of running and starting winding is connected to the phase terminal of supply. After successful connection, it is fitted back to its original position and connected to the electrical system. That brings us to the end of the lesson.